Look closely at how this group of fish is moving. In a standard 10-gallon tank, they are trapped in a tight, confined loop, darting erratically. Small volumes of water provide almost zero margin for error. A minor drop in room temperature or a tiny pinch of uneaten food can immediately alter the water chemistry, leading to sudden pollution spikes. Without enough physical floor space to claim a territory, bottom-dwelling scavengers and midwater swimmers are forced into constant, unavoidable proximity. That perpetual crowding triggers a continuous stress response, suppressing their immune systems. Keeping an aquatic community in a microtank is a relentless fight against physics. You are managing a biologically volatile pressure cooker. The most reliable way to stabilize that environment is to lean on a simple mathematical countermeasure. You double the capacity and move up to a 20-gallon tank. By increasing the total liquid volume, you instantly double the thermal mass, which locks the water temperature in place against outside drafts. That extra water also immediately dilutes the concentration of biological waste. This diagram shows how toxic ammonia rapidly builds up in a small, confined area. As it expands to double its original size, those exact same ammonia particles spread out, giving the nitrogen cycle capacity to safely process waste without fatal toxicity spikes. But 20 gallons is only a measurement of liquid capacity. It tells you absolutely nothing about the actual habitat architecture. A 20-gallon high and a 20-gallon long aquarium hold the exact same volume of water, yet their varying physical proportions create entirely incompatible ecosystems. This wireframe maps out the vertical geometry of a standard 20-gallon high. It has a 24-inch footprint, but notice the deep 16-inch vertical water column. This specific shape is engineered for tall aquatic plants to stretch upward toward the light, and it easily accommodates deep water fish that prefer to navigate vertically. But for bottom-dwelling species like Corydoras catfish, this shape fails. The floor space is virtually identical to a much smaller 15-gallon tank. Their usable horizontal territory has not increased at all. If you take that exact same volume of water and stretch it into a 20-gallon long, the tank drops down to 12 inches in height, but extends into a broad 30-inch horizontal runway. By elongating the shape, you dramatically increase the water's surface area. That wide top layer maximizes the physical exposure to the air, pulling a high volume of oxygen down into the water while allowing carbon dioxide to escape. The physical shape of the glass actively dictates the chemistry inside. A horizontal design drives oxygen exchange just as effectively as the mechanical filter on the back. Watching this synchronized school of fish dart across the frame illustrates why horizontal geometry matters. Their evolutionary instinct relies on rapid lateral movement. A 30-inch length gives active species like Neon Tetras an uninterrupted runway to naturally swim back and forth. A taller, narrower tank physically blocks that behavior. It also creates a highly effective spatial zoning grid. With an extended footprint, bottom feeders can stake out their own wide territories on the gravel, completely distinct from the mid-level schooling fish above them. By giving incompatible species the physical room to inhabit distinct spatial zones, the geometry of a 20-gallon long actively engineers peace. While proper geometry builds a highly stable environment, it does not make the ecosystem self-sustaining. The popular rule of 1 inch of fish per gallon completely ignores biology. A single 4-inch goldfish produces drastically more biological waste than 4 1-inch tetras. Safe stocking limits are dictated by the actual mass and waste output of the species, not just physical length. Perfect geometry only extends the timeline before toxicity sets in. It can never replace the non-negotiable requirement of changing 20 to 30% of the water every single week. When you maintain that strict schedule and respect those spatial zones, a fully realized, balanced community emerges. The chaos of a cramped tank is replaced by biological harmony. Upgrading an aquarium is an ecological decision. You are taking the physical architecture of a glass box and aligning it with the evolutionary behaviors hardwired into your fish. To find the right setup for your specific spatial zones, check out the TankZen blog. You can dig through species compatibility charts and find the exact 20-gallon kits engineered to support your chosen ecosystem.